This is our ME 475 final project by Daniel and James, where we performed an analysis on the Carver bike below. 3 different designs were analyzed. The first was our reference design that was made from steel tube with the following properties. The thickness and diameter of the tubes corresponded with the values used in the reference document. The frame weighed 5.01 pounds, the fork weighed 2.42 pounds, and the total weight was 7.43 pounds. The second design was made from an aluminum tubing with the following properties and had the same thickness and diameter as the reference design. The frame weighed 1.79 pounds, the fork weighed 1.28 pounds, and the total weight was 3.07 pounds. The third design was made from the same aluminum as the second design, but the thickness of the tubing was increased by 50%. The frame weighed 3.49 pounds, the fork weighed 1.93 pounds, and the total weight was 5.42 pounds. 3 loading scenarios were considered. First was the front drop that was simulated in the reference document. The second was the full drop, which simulated both wheels hitting the ground at the same time. And the third was a side impact on the rear tire. The reference design had the least deformation at 1.68 millimeters for the front drop, followed by the third and second design with 7.24 and 16.9 millimeters respectively. The max deformation for all designs occurred at the bottom of the fork. The third design had the least combined stress at 75.3 megapascals for the front drop, followed by the reference and second design with 119 and 168 megapascals respectively. For all scenarios, the maximum stress was at the head tube. A modal analysis was then done on all 3 designs for the front drop, where they all had a very similar first natural frequency between 23 and 24 Hz. Next was the full drop scenario, where the reference design had the least deformation at 20 millimeters, followed by the third and second design with 30.4 and 56.5 millimeters respectively. The third design had the least combined stress at 222 megapascals for the full drop, followed by the reference and second design, both with 411 megapascals. For all scenarios, the max stress was again at the head tube. A buckling analysis was then done on all 3 designs for the full drop. The reference design had the highest factor of safety at 3.92, followed by the third and second design with 2.55 and 1.38 respectively. Finally, the reference design had the least deformation of 199 millimeters for the rear impact, followed by the third and second design with 304 and 563 millimeters respectively. The maximum deformation occurred at the rear tire mounting points for all the scenarios. The third design had the lowest combined stress at 340 megapascals, followed by the reference and second design, where the stress was the highest at the head tube for all the designs. From the previous slide, the head tube had the highest concentration of stress, so it was analyzed using 3D elements for a more accurate analysis. The order of the designs did not change, but the stresses were reduced by about 30% and shows that the frame would be very close to breaking under this loading scenario. Looking at the results, the reference design was the best overall design, and for the extra 2 pounds, the steel frame had the strength and longevity that none of the aluminum frames can offer.